Hello YouTube, and we are on part 6 of our Linux from scratch series, and we are going to be doing chapter 7 in this video, and it is entitled Entering Chroot and Building Additional Temporary Tools. So if we click on the introduction, and let's just go and read through this. This chapter shows how to build the last missing bits of the temporary system, the tools needed to build the various packages. Okay. Now that all the circular dependencies have been resolved, a Chroot environment completely isolated from the host operating system, except the running kernel, can be used for the build. Okay, that's cool. For proper operation of the isolated environment, some communications with the running kernel must be established. This is done via a so-called Virtual Kernel File Systems, which will be mounted before entering the Chroot environment. You may want to verify they are mounted using the findmnt command. Until section 7.4, entering the Chroot environment. So, all right, okay. The commands must be run as root with the LFS variable set. After entering the Chroot, all commands are run as root. Fortunately, without access to the OS of the computer you build LFS on. Be careful anyway, as it's easy to destroy the whole LFS system with bad commands. Okay, so we were in this terminal here. We were root. We are root, and we're just going to check whether this environment variable is set. I can't remember, so let's do that now. Okay. Yep. So that variable seems to be set correctly, and we are root. So I'm just going to close this tab because I don't really need it. Right. So we go to, we'll just clear this down. Clear this down. I don't think we'll be using this because this is who am I? Yeah. So that's the LFS user. And this is the main terminal user. So we'll just make sure we use this tab. Right, we'll go next. Right, so it says change in ownership. Seriously, got it. Amazing. Browsers like all these pointless pop-ups is so annoying. The commands in the remainder of the book must be performed while logged in the user root and no longer as user LFS. Also, double check the LFS is set in the root environment. Well, I just did that, so we're good. But we'll do it again just to make sure. All right, we're good. Currently, the whole directory hierarchy is LFS is owned by the user LFS, a user that exists only on the host system. If the directories and the files under the LFS is kept as they are, they'll be owned by user ID without the corresponding account. This is dangerous because a user account created later could get the same user ID and own all the files under LFS, thus exposing these files to possible malicious manipulation. To address this issue, change the ownership of the LFS directories, basically they're the directories under our mount point, to user root by following running the following commands. So, okay, I'm just going to cd. So what does this do? So, right, so this changed ownership, and what is uname minus n? I'm not sure what this does. Let's just ooh. Don't like that. All right. Let's do that. What does that do? Right, okay. So I'm not sure what new name does. Print system information. Okay. Oh, what is it? So what's always print machine hardware name. So okay. Right, okay. Okay, I think I understand what this does. So let's just run this. Okay, I think that's okay. That ran without any issues. If I do LFS, yeah, I think we're okay. I'm not great with all the ownership types and all those commands. I'll probably do some reading after this about this. This is stuff I'm not too sure about. Right, so this is preparing a virtual kernel file system. So this is part 7.3. Applications running in user space utilize various file systems created by the kernel to communicate with the kernel itself. These file systems are virtual. No disk space is used for them. The content of these file systems resides in memory. These file systems must be mounted in the LFS directory, $LFS directory tree, so that the applications could find them in the Chroot environment. Right, so it needs these to operate by the looks of it when we go into their environment. I'm pretty sure you do something similar in Arch Linux. I could be wrong when you do an install on that. I haven't done I always use the Arch install now if I'm installing Arch Linux because it's easier. I have done a Arch install like manually, but I don't fancy ever doing that again. It's I find it a bit tedious, to be honest. Begin by creating the directories in which these virtual file systems will be mounted. So we're just making, so this is dev proc sys run. Okay. So we'll just do what is going on my keyboard. There we go, that's better. Right, so let's create those directories. They're all in the LFS. They are where I expect them to. I think Debian's got the same directories, I would imagine. So if we do cd proc, what is it? Dev. Yeah, dev is the devices. Proc, sys, and run. I'm not what I need to brush up on my file system hierarchy because I've forgotten what these do. I'm sure this will actually tell us. So the whole point of doing this is a learning exercise for me and for the viewer. So let's just close this terminal. And we'll go back to our root. Clear the screen. Mount in the section 7.3.1, mounting and populating dev. During a normal boot of the LFS system, the kernel automatically mounts dev temp fs file system on the dev directory. The kernel creates device nodes on that virtual file system during the boot process or when a device is first detected or accessed. The udeb daemon may change the ownership or permissions of the device nodes created by the kernel and create new device nodes or Symlinks to ease the work of distro maintainers and system administrators. I might read that later, actually. I'm not going to bore everybody reading that now. If the host kernel supports dev tempfs, we can simply mount a dev tempfs at lfs/dev and rely on the kernel to populate it. Some host kernels lack dev tempfs support. These host distros use different methods to create a new container dev. So the only host agnostic way to populate the $lfs/dev directory is by mounting the hosts/dev directory. A bind mount is a special type of mount that makes a directory subtree or a file visible at some other location. Using the following commands to do this. Now, I think Docker does bind mounts, but I'm not sure if it's the same terminology. So we'll run this. Right, so, okay. That is now mounted in there. Okay. So mounting the virtual kernel file systems. Now, mount the remaining virtual kernel file systems. Right. So, right, let's just read this. Meaning the mount options for dev PTS. This ensures that all dev PTS create device nodes are owned by group ID 5. This is the ID we use later on the TTY group. So your TTY is that you get several TTYs in your Linux distro. You can switch to them out of your GNOME if you want to, or whatever GUI you're using, and just use those straight away. I'm not like a super Linux expert, so I'm not. I forget exactly what TTY. What is it? Wait a minute. TTY is one of those funky Unix commands that prints the name of the terminal connected to the standard input. TTY is a text out. Yeah, so when you can get into like a router using like a serial connection, and then you get a TTY. Yeah, so it's basically a text only terminal. Okay. Close that, and let's go back to the mode equals 0620. This ensures that all dev PTS create device nodes have a mode of 0620, user readable, writable, group writable. Together with the option above, this ensures that dev PTS will create a device nodes that meet the requirements of grant PT, meaning that glib the PT underscore chown helper binary, which is not installed with default, is not necessary. Okay. That was a bit of a mouthful. So let's run that. This is just mounting more stuff. Right. So we've mounted that. In some host systems, dev SHM is a symbolic link to a directory, typically /run SHM. The run temp fs was mounted above, so in this case, only a directory needs to be created with the correct permissions. In other host systems, dev SHM is a mount point for a temporary file system, basically. In this case, the mount point of /dev above will only create dev shm as a directory in the Chroot environment. In this situation, we must especially mount a temp fs. I always laugh when I say that because I want to go shoot. Okay, well, right. So what does this do? Be honest, I'm not sure. Run it. Cool. So that looks like it ran correctly. Okay, and we're going to enter the chroot environment. Right, what does it say? Now, all of the packages which are required to build the rest of the system rest of the needed tools are on the system. It's time to enter the chroot environment and finish installing the temporary tools. This environment will also be used to install the final system as user root. Run the following command to enter the environment that is, at the moment, populated by nothing but temporary tools. Okay? So this is, you kind of do this on Arch Linux when you install, you manually install Arch Linux. You enter the chroot environments to complete the installation. So this is pretty much similar. So what this does is we chroot in the LFS directory, and I think this sets a bunch of environment variables. So home term PS1, okay, path, set some paths, the make flag. So that's your J. That's basically how many processes you tell make to use. We've got 4 on this machine, so this will be evaluated to J4. Test suite flags J4, so this is the same, and that is a bit of login prompt. So this is, we chroot in, we set a load of environment variables, and we run a login shell on bash for the looks of it. I think. LFS chroot, I have no name. Okay, cool. Guess that's because we don't have a host name. Yeah, and all this bit, I'm not going to read it out. Basically, that will just say if you want to if you don't want to use all your logical cores in your processor on your machine, change it to another value. Right, the IOPS gives you the env command will clear all the variables in the chroot environment. After that, only home term PS1 path. Okay. And variables are set again. The term construct sets the term variable inside the chroot to the same value as the outside chroot. The variable is needed so programs like Vim and Less can operate properly. If other variables are desired, such as C flags and CXX flags, so the C++ flags, this is a good place to set them. From this point on, there is no need to use the LFS variable anymore because of all the work will be restricted to the LFS file system. In the chroot command runs the bash shell with the root directory set to LFS. So we do ls. We are basically, this is the file system we constructed in previous chapters. Notice that tools bin is not in the path. This means that the cross tool chain will no longer be used. Okay. Also, that the bash prompt was so I have no name. All right. This is normal because the etc password file has not been created yet. I thought it'd be because no host name, but okay, that makes sense. Just don't have a username. Okay. Yeah, so this is just saying that we have to make sure we run it in the chroot environment, and we have to, we exit this, we have to go back in here on, yeah, we have to go back into the chroot. If you've done an Arch Linux manual install and you need to change some bits, like you've messed something up and you haven't built it properly, you go back into your Arch installer. So you go back into you mount all your partitions again, and then you chroot in to your Arch installation and fiddle about until you get stuff working again. This is essentially the same thing. And I've done this before. All right. Next, we need to create some directories by the looks of it. Create some root level directories that are not limited, not that, I can't read today. Create some root level directories that are not in the limited set required in the previous chapters by issuing the following command. Okay, let's go. So we cut and paste that in. So, right, let's read it properly. It is time to create the full directory structure in the LFS system. Right, he's just saying that we've already done them, but running them again is not gonna. See, this is why they got make DP is make DP is I forget the word for it, where you can run the command again and again. I've totally forgotten the term for it. So right, let's run this. So we'll just make some directories here. Yep. So those are created. Create the required set of subdirectories below the root level by issuing the following commands. Okay. So this creates a load of directories by the looks of it. There's Symlinks, some directories or files by the looks of it. Run log looks like a file, I think. And what does install do? Oh yeah, I don't have a man page in this environment. Copy files and set attributes. Okay, wasn't aware of that. Oh, that's exactly what it does. Right, there we go. That's good. So let's just run this through. Ah, no, I don't want to do that. Misclicking today. So I'm in the wrong. I went in the wrong directory. I need to do this wrong user. And that is another. That's why he has you run it as the LFS user, because I could have probably like bungled this, broken this Debian thing. That's twice I've done that now. I need to be more careful. Yeah, there we go. Okay, cool. That works. Right, it says here directories are by default created with permission mode 255, but that's not desirable everywhere. In the commands above, two changes are made: one to the home directory of the user root, and then another to the directories for the temporary files. The first mode ensures that not just anybody can enter the root directory, just like a normal user would do with his or her own home directory. The second mode change makes sure that any user can write to the temp and var temp directories, but cannot remove another user's files from them. The latter is prohibited by a so-called sticky bit, the highest bit in the 1777 bit mask. This looks like a magic number, or it's numerology. Directory tree is based on the file system hierarchy standard. That is what I've forgotten. So I should probably read that. I'm not going to read that on this video because it's, other people cover this to death on YouTube. The file system hierarchy standard also specifies the optional existence of additional directories such as USR local games and USR shared games. In LFS, we create only directories that are really necessary, however, feel free to create more directories if you wish. And then there's warning: the FHS does not mandate the existence of directory USR lib64, and the LFS editors decided not to use it. For the instructions in LFS and BLFS to work correctly, it's imperative that this directory be non-existent. From time to time, you should verify it does not exist because it's easy to create it inadvertently, and this will probably break your system. Okay. Right, we're on 7.6. Yeah, right. So creating essential files and symlinks. Historically, Linux maintained a list of the mounted file systems in a file called ECT-mtab. I remember that. I think it was probably back in kernel 2.4 or something like that, which is quite a while ago. Modern kernels retain this list internally and expose it via the /proc file system. To satisfy utilities that expect to find etc-mtab, create the following symbolic link. Okay, so this is older legacy programs. Okay. Create a basic etc host file to be referenced in some test suite and in one of Perl's configuration files as well. So this is like your basic etc hosts. So just setting where localhost is. I've not put this in an Arch installer, and I was wondering why I couldn't access localhost when I was developing some software, and it was because it wasn't in the host file. Because I skipped this part when I was installing Arch. So this is all very similar to bits and pieces doing Arch Linux. In order for user root to be able to log in and for the name root to be recognized, there must be relevant entries in the etc password and etc group files. Create the etc password file by running the following command. Okay. So all we're doing here is basically this goes and creates a file essentially. Right. The actual password for root will be set later. Okay. Create the etc group file by running the following command. I should say. So there we go. Come on. It's getting quite hot here in the UK. Well, relatively hot for the UK. I've got sticky fingers. Like 20, 24 degrees now. But you don't need to know that. The create groups are not part of any standard. They are groups decided on in part by the requirements of the UDEV configuration in Chapter 9, and the part of common conventions employed by a number of existing Linux distributions. In addition, some test suites rely on specific users or groups. The Linux standard-based LSB available at the there's a link there. I won't read it out. Only recommends that besides the group root with a group ID GID of 0 and a bin with the GID of 1 to be present, the GID of 5 is widely used for the TTY group, and number 5 it's also used in etc fstab for the dev PTS file system. This is a real mouthful. All other groups' names and the GIDs can be chosen freely by the system administrator, since well-written programs do not depend on GID numbers, but rather use the group's name. Okay. The ID 65534 is used by the kernel for NFS and separate user namespaces for unmapped users and groups. So that is... I think that's the number of the maximum number that you can have in 16-bit integer. I think those exist on the NFS server or the parent user namespace, but do not exist on the local machine or in a separate namespace. We'll assign nobody and no group to avoid an unnamed ID, but other distros may treat this ID differently. So any portable program should not depend on this assignment. Okay. Some tests in Chapter 8 need a regular user. We will add this user here and delete the account at the end of the chapter. Okay. So let's run this. To remove the I have no name prompt, start a new shell. Since the etc password and etc group files have been created, user name and group name resolution will now work. So basically create the shell inside the shell. Okay. Right. I'm now root by the looks of it. The login, Getty and init programs and others use a number of log files to record information such as who was logged into the system and when. However, these programs will not write to log files if they do not already exist. Initialize the log files and give them proper permissions. Okay. That worked. So WTMP file records all logins and logouts. Last log file records when each user was last logged in. The fail log file records failed login attempts. Okay, and BTMT file records the bad login attempts. The run UTMT file records the users that are currently logged in. This file is created dynamically in the boot scripts. Okay. Right, so these use 32-bit integers for timestamps. If I'm still using this in the year 2038, I'll worry about this note then. I suspect that's not going to be the case. I probably won't ever want to go through this again, to be honest, unless it's to create an automated Linux from scratch. Right, so we're on 7.7. So this is Gettext. The Gettext package contains utilities for internationalization and localization. These allow programs to be compiled with NLS native language support, enabling them to output messages in the user's native language. So, okay. So I think we just need to go. I guess I have to go to sources. And I think it's types. Then and then so it's just the usual configure step. Yeah, so this is just disable shared libraries. That's it. So okay. Right, that's the configure step. Let's do the make step. Right, so that's compiled them. And then the last step is install message format, message merge, and Gettext programs. Okay. So this just copies these files into our USR bin directory. Right, that looks like it worked. And then we're installing Bison. Bison package contains a password generator. Okay. So we do CD and then RM minus RF. Gettext. And then I need to do, let's just clear the screen. Let's make this a little bit bigger. Tar XF. Bison. CD Bison. And be a configure set. Now, originally I said I don't care about these SBU units, but now I understand why he talked about them, because I know when I can walk away from the computer and just let it run if it's a larger value. Okay, if it's like 0.2, I know it's going to happen like relatively quickly. Oh, I didn't read the meaning of the new configure option. So this is docdir tells the build system to install the Bison documentation into a version directory. Okay. That's just where it puts docs. And then we do make. Right, and that appears to have worked correctly. So we install Perl. I actually got a Perl book and then never learned how to use Perl. I have done a bit of Perl program, but it's a long time since I've done any Perl program. It's kind of required, like it's that little secret that's everywhere. So installation of Perl. So before that, we have to always remove the directory. So this is just a bit of cleanup, essentially. And what we do now is, yeah, that's right, yeah. Bit worried there, I deleted the wrong thing. So tar xf, and then it's going to be Perl, boom, and we'll do a configuration. Just run the configure step. Right, meaning of the configure options. Let's just make sure we understand what we're doing. DES, this is a combination of three options. D uses defaults for all items. E ensures completeness of all tasks. S silences non-essential output. Okay. The dash capital D vendor prefix ensures that Perls know how to tell packages where they should install their Perl modules. Okay. /D uses srp lib. Build lib Perl needed by some Perl modules as a standard shared library instead of a static library. Okay. Privlib, archlib, and sitelib. So these settings define where Perl looks for installed modules. Okay. So Perl has like most programming languages have a module system, and that's basically telling it where it can go and look for certain modules when you import them, I guess. It's been a long time since I've done any Perl programming, and I did do very much at the time. The LFS editors chose to put them in a directory structure based on the major minor versions of Perl 5.40, which allows upgraded Perl to newer patch levels. Patch level is the last dot separated part in the full version string, like 5.40.1 without reinstalling all the modules. Okay. That makes sense, because a patch version is just a bug fix. Typically, it should be a bug fix. If it's using the sort of like the semantic version, and so semantic versioning, if you're not aware, is major, minor, bug fix. So major version is Perl 5. The minor version is 4.0. So there was, I'm guessing, 39 versions before this, and this is the patch 1, I'm guessing. I think that is, I have to check if that's actually correct, but that's typically how it works. Then compile the package. So we need to first cd into Perl, which I didn't do, and then run the configure step. sh configure. Okay, this is a little bit different. And then we do make, hopefully this shouldn't take too long. Right, okay, that wasn't too bad. We make install. Boom, done. Install Python. Okay. So Python should really need no introduction. The Python 3 package contains a Python development environment. It's useful for object-oriented programming, writing scripts, prototyping large programs, developing entire applications. Python is an interpreted computer language. As I said, it really needs no introduction. There are two package files whose name starts with the Python prefix. The one to extract is Python 3.12. Okay, so before we do this, we have to cd out of here. rm minus rf. So there we go. And then we need to make sure we do the one with the Python 3.13.2 with the uppercase. So these, I think I've read these out. Ensure shared. And we install it without pip, basically. So let's do the configure step. So that's all that does, is those two configure options. So the only one to note that's different really is that without ensured pip. So we need to cd into there first. Keep forgetting to do that. There we go. All right, and then we do make. Right, so while that's compiling, let's read this note. Some Python 3 module can't be built now because of the dependencies are not installed yet. For the SSL module, a message Python requires OpenSSL 1.1.1 or newer is outputted. This message should be ignored. Just make sure that the top level make command has not failed. The optional modules are not needed now and they will be built in chapter 8. Okay. Right, and now we do make install. Right. Next thing to do is, so what we need to do is we cd out here, rm minus rf. Yep. So that's correct. And then we install Texinfo. The Texinfo package contains programs for reading, writing, and converting info pages. So info pages are kind of like, they're like alternative to man pages. Both are usually in a Linux system. Robert Elder actually has a really good video about info pages and man pages on his channel. So you should probably check that out. In fact, I'll put that in the descriptions because it's a really good informative video. So we do tar xf text Texinfo. Yeah, there we go. cd Texinfo, and we run the configure step. There's no options on this one. All right, and then we do make then make install. I was worried I'd run make twice there. And what we do, cd out there, rm minus rf Texinfo 7.2. Then we do bump. And then utils, we're going to be installing Util-Linux. So Util-Linux package contains miscellaneous utility programs. The file system hierarchy standard recommends using the var lib hardware clock directory instead of the usual etc directory as the location for the adg time file. Adjunct time. Some of these things are a mouthful to say. Create this directory with the following. Okay, so just create the directory. Yep. And we have to again xf utils linux cd utils linux, and then we do configure. Right, I didn't go through the configure options. So this right, so this goes and just sets the. I won't read this whole thing out. It's a bit tedious. That basically sets this tells it where the location of the file will exist, and the reason they haven't they set it here, even though these temporary tools, is because you'll have this in two locations and you'll have to remove it later. There's no point, so you might as well just create it there. libdir usr lib, the switching ensures the SO Symlinks targeted in shared library file in the same directory. Right, so that just goes and is that English? The switch ensures the .so Symlinks targeted the shared library file in the same directory. That's almost not English. And these are disabled as command line switches, so there's a bunch of options here. Yeah, so this switch disables using Python. Run state dir equals 1. Switch sets the location of the socket used by the UUID and the lib UUID correctly. Yeah, okay. I forgot the UUIDs are like a unique identifier that's based on the hardware clock. and a random seed. I think they are predictable apparently though. People use them as IDs, but it's whatever. We've done the configure step. We do make. Then make install. Okay, cool. I saw some red there. What was that? Oh, it's just a warning. That's fine. Cleaning up and saving the temporary system. So, right. So, cleaning up and saving temporary system. So, cleaning. First, remove the currently installed documentation files, prevent them from ending up in the final system, and save about 35 megabytes. Okay. 35 megabytes on a disk is like, you can forget about it, but I suspect it. They won't have files hanging around if you don't need them. Second, on the modern Linux systems, the libtool.la files are only useful for libltdl. No libraries in LFS are loaded by libltdl, and it's known that some .la files can cause BLFS package failures. Remove these files now. So let's do that. That removes the files. The current system is now about 3 gigabytes. However, the tools directory is no longer needed. It uses about 1 gigabyte of this space. Delete it now. Okay. Right. So let's just delete that tool. So let's do one thing at a time, because I'm reading about this backup stuff, which is not what I was just talking about. Right, so we'll just run that. Right, so this is basically, we're at a point. What he's saying here is you're at a point now. I won't read this out, the whole thing out, because it's not necessary to do. This is a set of optional steps. I'm going to do them because I don't want to have to do all the other things all over again, because it's quite lengthy and I prefer not to do it again. So what we're going to do, this will be quite useful because I actually want to reinstall my actual host system because it's kind of a little bit broken. Everything's running well enough, but there's some annoying bits and pieces. So I might want to actually back up and then take that back up and then put that onto a disk somewhere. So this would be quite good to have, actually. So right. So what this looks like it does is we have to, right, so let's just exit. We can always re-enter. And we're as root, and we have to unmount these. Guess I'll have to remount them before the next video. And then we'll mount this. And we'll do the same again on this. Right, so that's that done. And then, right, so make sure you've got 1 GB of free disk space. Now I gave this 25 GB, so let's do df -h. Available 1.5 gig. Okay. I almost ran out of space. Look, 1.5 gigabytes. I might have to make this VM a little bit bigger. Right, so we're gonna cd into LFS. We're already there, and then we're gonna tar up the whole directory. Hopefully I won't run out of room. So we are quite low on disk space. There was the disk space board and come up on there. I reckon we've got like maybe 500 megs left. If that. Yeah, 500 megabytes. So we're scraping a by, but I think we should be okay. So we've done a backup, and there's some restore instructions here. I won't bother going over those. Basically, you extract that that tar archive into here, so that yeah, this is like there's some warnings here. There's nothing to. Right, so, and it says right at the bottom here, if you left the Chroot environment to create a backup and start building using a restore, remember to check that the virtual file systems are still mounted. Okay, so let's just do that, because I'm pretty sure we're at the end of the chapter now, so we want to be ready for the next chapter. So I don't think they are, so there's only the that's only the LFS system is mounted. So go back here and we just mount so that I think we've already made that directory. So let's just echo LFS. Yep. So we need to run this again. And run this again. And we have to run this again. So right, that's mounted. And then if we go back again, preparing the virtual kernel, entering the Chroot, we need to run this again. We are in there. That's good. So what I've done is we just reran those instructions after doing the backup because you exited the Chroot shell. Basically, you need to remount those and then run this again. And then we go on to the next. And this is chapter 8. Now, this is going to be a long chapter. So hope that this is going to be the next thing's going to be a very long video, I'd imagine, because it's going to take a while to go through all of these. Well, that's all for this video anyway, and I'll see you in the next one. Bye-bye.